Okay. I'll explain once more. Listen, velocity of rain is vertically downwards. That is given in the question. Velocity of rain is 35 meter per second. So we represent it with the letter VR. V means velocity, R means rain. Velocity of rain. Velocity of rain is given 35 meter per second. You know, it is always vertically downwards. And another velocity is given. Velocity of the wind is given. So VW, we represent it with the letter VW. W means what? Wind. V means what? Velocity. Velocity of wind, VW. VW equal to 12 meter per second. So that also we represent with this letter VW equal to 12 meter per second. So here as the boy is standing on the bus stop. So what direction he should hold his umbrella? That is the question. So if there is no wind, which direction he should hold his umbrella? Vertically upward, like this. Vertically upward. But as the wind is blowing, velocity of rain's direction will be different. We know, everybody knows that. When the wind blows, the direction of rain also changes. So we should know the direction of rain, and opposite to that, we should hold our umbrella. If wind is blowing like this, we should opposite that. Like this, you have to hold our umbrella. Like this. Like this. Umbrella you have to hold like this. The person is standing here. Velocity of rain is downwards. Velocity of wind is in this direction, towards west direction. So what he should, in which direction? Opposite to that, he should hold his umbrella. So first we have to find out resultant velocity of rain, and we should hold our umbrella opposite to that. Okay. So what is the resultant velocity of rain? We have to find out resultant velocity. Velocity of rain is downwards. Velocity of wind is towards west. So what is the resultant velocity of rain? So how will you find out? Now you have marked these two velocities as the sides of a rectangle. Those two velocities are marked as the sides of a rectangle. And you complete the rectangle with the dotted lines. We completed the rectangle and draw the diagonal. Draw the diagonal from the point where we have marked the two velocities. From that point you have to draw the diagonal, because other diagonal is also possible. This diagonal is also possible. That will not give the resultant. The resultant is given by the diagonal drawn from the same point of intersection of the two vectors. According to parallelogram law of vector addition, the diagonal drawn from the same point from where we mark the two vectors. So from this point we mark the two sides of the adjacent sides of the parallelogram. So the diagonal drawn from that point itself will represent the resultant of these two vectors, or the diagonal drawn from the same point of intersection of these two vectors. From here you draw the diagonal to complete the parallelogram. We have already completed the parallelogram, and you just have to draw the diagonal. That will give the resultant of VW and VR, velocity of rain and velocity of wind. Resultant velocity is given by the diagonal drawn from the point of intersection of these two vectors. Okay. So how will you find the resultant? Resultant formula while studying the derivation part, we got the formula. Derivation part, R equal to root of, I will show the formula. This formula we have studied. You see this formula, root of A square. A is the one vector, B is the other side of this parallelogram. A is one side of the parallelogram. So R equal to root of A square plus B square plus 2AB cos theta. Theta is the angle between A and B. And A is one vector at the one side of the parallelogram. B is the other side of the parallelogram. These are two vectors, and theta is the angle between them. So let us apply that formula here. Cos.
Teacher,
Ah,
പവിത്രൻ അഡ്മിറ്റ് ചെയ്യാൻ പറഞ്ഞു.
so this formula you have to use here. Parallelogram law of vectors. The magnitude of the resultant vector is given by root of a square plus b square plus 2ab cos theta. This formula you have to use here. I will apply the formula here. Root of vr square plus s square plus b square plus 2ab cos theta. What is theta here? Angle between VW and VR. What is the angle between VW and VR? 90 degree. So what is cos 90? Cos 90 is 0. So that term is not written here. When two vectors are perpendicular, you can directly use this formula. Root of VR square plus VW square. What happened to the other term? Plus 2ab cos theta. What happened to the other term? Cos 90. Cos 90 is 0. 2 into VW into VR into 0. So that term disappears. That becomes 0. So no need to write that term when two vectors are perpendicular. That is the case of parallelogram. Now this is a rectangle. Angle between VW and VR is 90 degree. So the third term will not be there. We can just use the formula root of VR square plus VW square because they are perpendicular. So substitute 35 square plus VW is 12. So 12 square and we get the answer. Finding the square root, you get the answer 37 meter per second. That gives only the magnitude and the magnitude of the resultant velocity of rain. Resultant velocity, see, actually rain velocity 35. Velocity of the wind 12. Resultant velocity, you see, changed, increased. Velocity of the rain is increased. Resultant velocity is 37 now because of the wind blowing towards west direction. Resultant velocity's magnitude is changed. Wait. So we try again. Maybe next problem. Okay, so resultant velocity of rain is increased and also which direction also is changing. Direction, which what is the direction? Let us see. By finding tan theta, that means direction of rain. See, now this is the resultant velocity. Velocity of rain is in this direction. So this angle, how will you find? That's the question. So that also we have derived that also. Show that formula. So this direction is given by this angle. Here you have to mark this angle here. Tan theta will give the direction. Tan theta is opposite side by adjacent side. If this is VW, this also will be VW. Parallelogram. So this is VW. This side also will be VW. And this side, adjacent side will be VR. So here you have to mark that angle. I forgot to mark that angle here. When I send it, I will mark that angle here. This is angle theta. That means with respect to the rain, what direction we should hold our umbrella? With respect to the rain, what direction we should turn the direction of the umbrella to protect us from the rain? Because of the wind, the direction of the rain is changed, and with what direction we should hold our umbrella? That in order to find that direction, we should find tan theta. Tan theta is opposite side by adjacent side. VW by VR. VW by VR. 12 by 15. 12 by 15. That's equal to 0.343. And this is only tan theta. For finding theta, we have to find the inverse value, angle. About 0.343, we cannot tell what angle we should hold our umbrella. That we don't know. So that inverse value we have to find out. That means corresponding to this value, 0.343, what is the angle? Corresponding to this value, what is the angle. For that, that is why I asked you to buy Clark's table. I put the message in your group. All of you have to get Clark's table. Sometimes you may get it from your brother or sister or cousin, like that table will be available with them, or you have to buy one table. So I am giving you time during this vacation class. We are having special classes, and at that time you bring one class. We can along with our portion, we can take that also, how to find angle corresponding to a value, how to find angle, or corresponding to an angle, what is the value, tan 45, tan 90, what is it, അല്ലെങ്കിൽ tan 15, what is it, or sin 16, what is it. All values you can find out using Clark's table. So all of you get one Clark's table. During the first class itself, you can study how to find the angle corresponding to a value. Corresponding to a value, what is the angle, that you will get it from the Clark's table. Any, if it is tan, or if it is sine, if it is cos, any angle you can find using Clark's table. So all of you try to get a Clark's table from your friends, or from your cousin, or from your brother or sister, or from the shop. Try to get it when Clark's table, because we have to find angle. For an angle, corresponding value, natural logarithm of that, or from the value, you can find the angle corresponding to that. So by just by writing 90 degree, you will not understand how you got that value. You will not understand. For that purpose, you have to get Clark's table. I put the message in that in your class group. Okay. But next class, I think I hope all of you will get that table with you, and we can discuss how to find this angle. Okay, so we can move to the next page. So he should hold an umbrella 90 degree, like in this direction. So if I extend this into this direction, 90 degree from the vertical, like this, and umbrellas protecting part, that means that cloth part of the umbrella must be here, 90 degree towards east. You have to hold from the vertical, 90 degree towards east. You have to hold the umbrella. Okay, that you have to write. It is a problem which is discussed in your textbook. Textbook worked out problem is this. So go through that. Next is very important portion, resolution of vector. Resolution of vector. Now what we have studied, addition of vectors. Addition of vectors. That means combining two vectors, we got one resultant vector. That is what we have discussed. Combining two or more vectors, we get a resultant vector. Resultant vector is that vector which gives the same effect as is done by the individual vectors. Now we are going to split a vector into component vector. That is the reverse process. What we have studied, combination of vectors. Next, what we are going to study, resolution of vector. A vector is resolved into its component vectors. So resolution means splitting of a vector into its component vectors. So what is resolution? It is the process of splitting a vector, single vector, into two or more vectors in different directions, which together produce, the component vectors together produce the same effect as is produced by the single vector alone. The vectors into which the given single vector is splitted are called component vectors. So what we are going to do now, everyone should have idea what we are going to study. What is our objective? What is our objective? We are going to resolve a single vector into its component vectors. What is the benefit of that? The component vectors together will produce the same effect as is produced by the single vector alone. So now we are going to split a vector into its component vectors. Now I will show the figure. First is explanation. The figure is in the next page. You can see this figure. This is the figure. A is one vector, direction is given, magnitude is given. B is another vector, it is upwards, and its direction is also shown by the arrow mark. So what is given to you? Two vectors, vector A and vector B. And what is the question? You have to 82 only. Anybody waiting? Nobody waiting. Priya is waiting. Okay. Now we are going to split vector. Vector A is drawn here. Blue pen that is drawn. Vector A. Let us represent OP. Vector OP is the given vector. What is given to you? Vector A. And one more thing, it is given A and B are also given component vectors. We have to split this vector A into two components. You cannot split in any way. You have to split in the given two direction. Vector A is in this direction. So you have to take a component of this vector in this direction. You have to get to another vector, vector B, in this direction. So what is our aim? We have to split vector A in the given two directions. That is our aim. What is our aim? We have to resolve vector A. We have to split vector A. Which direction? In the given two direction. Two directions are given. In those two directions only you have to split that vector. Understood? You have to split this vector in the given two directions, not in any other direction. You have to split the given vector A in the given two directions. Very easy. Very easy. First vector A is drawn with same magnitude and same direction. Vector A is drawn with same magnitude, same direction. Okay, vector A is drawn. Then what is to be done? Next step, you just draw from O, you draw a line parallel to A. No need to measure direction. No need to measure the magnitude. If suppose this may be having 3 centimeter, you just don't mind that. You just draw a line from O parallel to A. No need to measure the magnitude, only to see the direction. So from O, you draw a line parallel to A. That is very easy now. We are not at all measuring the magnitude. Just you are asked to draw a line parallel to this vector. So that's very easy. We have drawn without measuring its length. You have drawn a line parallel to this vector, given vector A. Okay, that is done. Next, what is your next part of splitting that vector into this direction? Also, you have to split. You have to find the component also in this direction. So what is that also is very easy. From point P, draw a line parallel. No need to measure the magnitude. Whether it is 5 centimeter, 4 centimeter, no need to measure. You just have to draw a line parallel to this vector B. So from P, you just have drawn a line parallel to B. Orange color, orange color. Here also I have drawn that vector with orange color. So no, I haven't measured the magnitude. Magnitudes are really different. So I have drawn two lines and I have seen they are meeting at the point Q. They are meeting at the point Q. So now we got the component. Very easy. Very easy. We got the components now. Now vector OQ represents the vector which is parallel to vector A. That will not be the same vector because its magnitude is increased now. It have become lambda, a real number times. It may be sometimes 5 times, sometimes 6 times, sometimes 5.5 times, like that. Lambda, we just write, as it is an equation, we just write lambda times vector A. Direction is same. Magnitude is changed. So you just write, it is lambda times vector A. And this one, Also, this is not, this is maybe 2 centimeter, but this is, it is another quantity. Sometimes 7, sometimes 8, sometimes 4, like that. It is different. So we'll just write it is mu times vector B. Direction is same. So it is, we write real number times. You have to measure it, how much. Then you have to write 7.5 times the vector B, like that you have to write. It mu times, we just write mu times vector B, and this is lambda times vector A. Now we got the component of this vector A in the given 2 direction. So vector A now we can write is equal to, vector A is equal to lambda times vector A plus mu times vector B. Now we got the components. This is the way of splitting a vector A into 2 directions. Not in any 2 directions, it is given direction. The 2 directions are given. You have to split the vector in the given 2 directions. And there is one and only one way in which a given vector can be splitted in the given 2 directions. Pranav is waiting. Pranav, every day you are late. Pranav, every day you are late. Why you are like this? You have to call me immediately. Pranav, now you have entered to the class. Every day you are coming late or absent. Every day I am marking absent. If it is due to the net problem, you have to correct it properly. You have to find out which net is strong in your house, and you have to get that network. Okay. Otherwise, it becomes very difficult to understand this physics and all. Very difficult to understand. So you have to call me after the class. You have to call me individually, and you have to tell the problem why you are not coming to the class regularly. So that you have to tell the reason to me after the class. Okay, now you have splitted this vector, and this is the way of splitting, and this is the way of answering. And how to split the vector, everything I have explained in the explanation. You have to read that. Next one. What I explained is written in the notes. Okay, what I explained is written in the notes. So last, what is written? There is one and only one way in which a vector can be resolved into 2 component vectors along the directions of the given 2 vectors. If the given 2 vectors are given, you have only one and only one way in which that vector can be split into the given 2 directions. Okay, that is written here. That is the important point there. And you should know how to resolve a vector in the given 2 directions. Next is very, very important one, most important one. This is applicable in this year, next year, every year we have to see this resolution of vector into rectangular components. Very, very important. Resolution of a vector into rectangular components. That means we are splitting a vector into 2 rectangular components. Rectangular means components in 90 degrees. 90 degrees. Components are in 90 degrees, not any 2 directions. Components are acting in 90 degrees. Perpendicular components, rectangular components. So you have first vector A is given to you. We have to split that vector A into its component vectors, and the component vectors must be perpendicular to each other. So the first step, you should know the rectangular coordinate system. That means here I, J, K are unit vectors along x direction, y direction, and z direction. I, J, K, I cap, J cap, K cap are the unit vectors along x direction, y direction, and z direction. So whenever you represent a vector along x direction, we write its magnitude, and this direction along x-axis is always, suppose I write 4i cap, 4i cap I am writing. For I cap means here from the origin at a distance 4 centimeter from it along the x-axis that vector is acting. That's the meaning. For I cap means for at a distance 4 centimeter from it along the x-axis that vector is acting. I cap means what? It is along the x-axis. I cap is the unit vector along x-axis. What's the magnitude? 1 centimeter. What's the direction? X-axis from the origin. It is acting. And I am telling for 5 jack-cap. 5 jack-cap. I am telling 5 jack-cap. What do you mean by that? 5 jack-cap. So from the origin, 5 centimeter from the origin, the vector is acting. Velocity is along y direction. 5 jack-cap. Velocity is 5 jack-cap. What's the meaning? Velocity magnitude is 5 and its direction is along the y-axis. Velocity is acting along y direction. What's the meaning? That is the meaning. 5 jack-cap means magnitude is 5 centimeter from the origin. And jack-cap means it is acting along y direction. Another vector I will tell. 7 jack-cap. What is meant by 7 jack-cap? 7 jack-cap means that vector is acting along the z direction. Jack-cap means that vector is acting along z direction. And what's the magnitude? It is 7 from the origin. Magnitude is 7 centimeter from the origin. That's the meaning. So I cap means what? It is the unit vector along the x direction. Jack cap means what? It is the unit vector along the y direction. Jack cap means what? It is the unit vector along the z direction. That's the explanation of this figure. What we are going to do? We are going to split vector A into its components along x and y direction. This is x direction, this is y direction. Okay. We are studying motion in a plane. We are not splitting the vector now into 3 dimensions. We are not splitting into 3 dimensions. Now we are studying the splitting of a vector in 2 dimensions. That is the motion in a plane. This is a plane. This page of this book is a plane. This page is a 2 dimensional. When the cursor move on this plane, this is a 2-dimensional motion. 2-dimensional. So we are going to split this vector A into 2 rectangular components. So first what I have done, first vector A is drawn with same magnitude, same direction. Then next step I will tell you, from this point, tail of the vector, you draw 2 mutually perpendicular axes. From O, draw 2 axes, x-axis and y-axis. Nothing difficult, very easy. You just have drawn 2 lines, x-axis, and marked it x-axis here, and you have drawn another line perpendicular to it, y-axis. Very easy now. Well, only 2 steps we have done. First, you have drawn vector A. I have drawn it with that green color, and I have written vector A here. Arrow mark is shown here, and O is the tail of the vector. And suppose this is another point P, like that. And next step, first I have drawn vector A. Okay, I think you understood. First I have drawn vector A and written also vector A. It is written. What all things are there? O is there, beginning point. Vector A is written. That is representing the direction of vector A, and arrow mark is put on it. And what next step? From O you drawn 2 axes, mutually perpendicular axis, x-axis and y-axis, and put arrow mark here. Here I have put arrow mark. Second step over. Third step, you have to draw perpendiculars from this tip of the vector. Draw 2 perpendiculars. Drop 2 perpendiculars to both the axes. Now I have drawn the perpendicular. It is meeting at this point. And that will be the component of this vector along the x-axis. Let us represent it by A1. A1, vector A1. Now we have to put a vector symbol here. Arrow mark. We have to put an arrow mark here. That is the component of this vector A along the x direction. Let us represent it by vector A1. Vector A1. What is vector A1? It is the component of vector A along the x direction. Next, I have drawn a perpendicular to y-axis also. It is meeting at this point here. So you have to put an arrow mark here. That is the component of this vector A along the y direction. There is, what we have done. We have drawn two perpendiculars. First, we have drawn the perpendicular to x-axis. So that is giving us the component of vector A along that direction. Vector A1 is the component of vector A along the x direction. And what is done next step? We have drawn a perpendicular, that means to the y-axis. Now, okay, that's enough. That will give the component of vector A along the y direction. Component of vector A along the y direction. We are represented with the vector A2. Now we got the two components, vector A1 and vector A2. Vector A1 is along x direction and vector A2 is along y direction. So now you can write the formula vector A equal to vector A1 plus vector A2. But we are not stopping with that. We have to take the components with magnitude and direction. Okay, I will show these lines. Consider a vector A that lies in xy plane as shown in figure. We draw lines from the head of vector A perpendicular to the coordinate axis as in figure and get the vectors vector A1 and vector A2. That is what I explained. Such that vector A1 plus vector A2 equal to vector A. Since vector A1 is parallel to I cap and vector A2 is parallel to j cap, we have so A1 we can write as AX here. A1, this is A1 I have written last page. A1 is AX, that gives the magnitude, and I cap is the unit. We are writing in terms of unit vector. A1 we are expressing in terms of unit vector. When we express with unit vector, first we write the magnitude because unit vector gives only direction. It is along x-axis. It tells only that one. It is along x-axis. That gives the I cap gives what it explains us. Yeah, though that vector is actually in x direction, that only it explains. Okay, so we have to write the magnitude. You have to measure this length only 5 minutes more. You have to measure its magnitude. So 5 times I cap, 5 I cap, we can write. Similarly, here this we are expressing in terms of unit vector along the y direction. This is j cap. So we write as it is along the y direction. We write ay j cap. Now we got A1 plus A2 equal to A. In the place of A1, we have to write AX I cap. In the place of A2, we have to write AY j cap. So we write the equation now. Vector A is equal to AX I cap plus AY j cap. Okay. Now another step. Some more steps are there. What is AX? What is AY? You have to find out how to find the magnitude. That with in terms of theta. In terms of the magnitude of vector A, we can express AX and AY. For that, we find this cos theta and sin theta. See, cos theta is written here, cos theta. Triangle, this triangle you take OP, this triangle. OP, let Q is written. You have to write Q here. So cos theta, adjacent side AX by hypotenuse AX by A. Similarly, sin theta, if this is AY, this also will be AY. So sin theta will be AY by A, opposite side by hypotenuse, AY by A. So AY equal to A sin theta, AX equal to A cos theta. That we have to substitute in this formula. AX equal to A cos theta, AY equal to A sin theta. That we have to substitute. So we substitute that there and we find the value of magnitude of A in terms of its component. So squaring and adding, you square this equation 2 and 3. Ax square plus ay square equal to S square cos square theta plus S square sin square theta, squaring and adding. So therefore we get S square into cos square theta plus sin square theta. That is 1. So we get S square. Therefore A equal to what? Root of, this is S square. S square equal to X square plus AY square. What is A? A equal to square root of X square plus AY square. Similarly, tan theta gives the direction, as we have done in that problem. Tan theta gives the direction. You just divide this 3 by 2, A sin theta by A cos theta, and tan theta equal to AY by AX. Divide A, 3 by 4 AY by AX. Tan theta equal to AY by AX. Therefore, theta equal to tan inverse AY by AX. Yeah, you will be having a doubt how to study this question. See, when you have to study as I have given in the notes, consider given vector A, we have to split that vector into two components along the x-axis and y-axis. For that, first you have to draw the perpendiculars to the x-axis and y-axis, and this will give the x component, this will give the y component. So vector A can be written as axi cap plus ayj cap. And how will you find the magnitude of ax and ay? For that, you have to find the cos theta and sin theta, and squaring and adding, you will get ax equal to a cos theta, ay equal to a sin theta, and squaring and adding, we get a equal to root of x square plus ay square, and theta, how will you find tan theta? You have to find out, and theta equal to tan inverse ay by x. All these steps you should be able to write without looking. That is the way of studying. Resolve the given vector into rectangular component. That will be the question. So you should be able to write all this. Understand? So write and study 2 or 3 times. Write and study. Draw the figure. Write and study. Okay. That is the way of writing. I will call the absentees' names. Gautam, are you present? Muhammad Adil. Pranav came. Okay. Pranav, you have to call me after the class. Then,
Muhammad Adil present.
Muhammad Adil present. Then Gramya, are you present? No, absent. I will mark absent now. Then Lakshmi Priya, are you present? Absent. Devika Sunil,